Okay, hello and welcome to everybody. We're about to begin. I see roughly 47 attendees, and some folks have yet to dial in. If you have not dialed in, please do so. Okay, hello and welcome to the Developing and Implementing a Stormwater Management Program in a Transportation Agency webinar presented by the Center for Environmental Excellence by AASHTO in cooperation with the Federal Highway Administration and the Federal Transit Administration. I just would like to first acknowledge our sponsors, introduce our sponsors and advisory panel members for their practitioner's handbook, and thank them for helping us facilitate this live online conference today, which include the AASHTO Center for Excellence and the Federal Highway Administration. The advisory panel that oversaw the development of this handbook includes Rachel Herbert with U.S. EPA, Kate Kurgan, Damon Fordham, and Wayne Kober with AASHTO, Pat Kazinas, Dan Gear with FHWA, Elizabeth Velasco with Federal Transit Administration, and representatives from the State Departments of Transportation, including Scott McGowan, Judy Ruskowski, Karuna Pujara, and Marcus Anderson. Your webinar presenters are myself, Anna Lanton, and Scott Taylor. We're both with RBS Consulting, headquartered in Irvine, California. Scott and I will be alternating as presenters during this webinar. The Center for Environmental Excellence by the American Association of State Highway and Transportation Officials in AASHTO has been developed in cooperation with the Federal Highway Administration to promote environmental stewardship and to encourage innovative ways to streamline the transportation delivery process. The center is designed to serve as a resource for transportation professionals seeking technical assistance, training, information exchange, partnership building, opportunities, and quick and easy access to environmental tools. The center develops and maintains a variety of products and programs. One of the important products is the Practitioner's Handbook. The handbooks provide practical advice on a range of environmental issues that arise during the planning, development, and operation of transportation projects. The handbooks are primarily intended for use by program and project managers and others who are responsible for coordinating compliance with a wide range of regulatory requirements. With our needs in mind, each handbook includes a background briefing, key issues to consider, and practical tips for achieving compliance. In addition, key regulations, guidance materials, and sample documents for each handbook are posted on the Center's website. Today we'll talk about the recently published Developing and Implementing a Stormwater Management Program in a Transportation Agency Practitioner's Handbook. This is handbook number 13. You will learn about some of the key elements of a successful working transportation stormwater management program for your agency. Using information taken from the Practitioner's Handbook on the topic, you will learn some of the methods to develop and implement a program that complies with the requirements of the Clean Water Act. You will also hear about some practical tips and transportation-specific references to help assist you with implementing your stormwater management program. Here you can see the overview of the webinar, generally describing the resources available in the handbook. Before we get started, a few housekeeping issues. So how to ask questions. You can enter questions in the online chat box as we proceed. There should be a panel there. If it's not in expanded mode, you can click and expand that, and you should be able to view the chat box. You can type in your questions, and we will attempt to answer as many of the questions received in the chat pane as possible at the end of the presentation. You can also send any follow-up question to the presenters. Contact information will be provided at the end of the presentation. After the webinar, this presentation will be available for viewing on the Center for Environmental Excellence website at environment.transportation.org. We will also post a PDF of the slides for future reference. You'll also be able to view and download the Practitioner's Handbook and its associated resource material on this website. It may take a few days, if not a week, and then we should get all that information on the website. So the purpose and objective of the handbook is to assist transportation agencies in developing and or implementing a stormwater management program that satisfies the requirements of the Clean Water Act. For agencies that already have a functioning stormwater management program, this handbook provides useful tips and transportation-specific references to assist in program implementation and refinement. As shown on the handbook outline here, we will discuss the following. Development and implementation of a stormwater management program. These are what are the basic required elements of your program. The Clean Water Act and the NPDES program. This will include a quick background on the regulations, state and local stormwater regulations. This will provide a general discussion on state requirements, conducting a program effectiveness assessment, a key element in an adaptive management of stormwater programs. Developing a stormwater management plan. These will include the nuts and bolts of a good plan. We will touch on public education and outreach, and then we'll talk about construction site stormwater compliance. This is an area of primary concern for most DOTs and is rapidly evolving with the new EPA promulgation of the Effluent Limitations Guidelines for construction. A recent AASHTO webinar was held on this subject and will be available on the Center of Environmental Excellence website. Integrating best management practices into transportation project delivery will also be discussed. Now we'll touch on roadway maintenance stormwater practices and the NPDES compliance. Next is on total maximum daily loads and other special requirements. This is a program element which will be exceptionally important for most DOTs in the near and medium term as it begins to consume more program resources. Important stormwater management terms will also be discussed. Here's a snapshot, the screenshot of the Center of Environmental Excellence website and the Practitioner's Handbook where the publications can be downloaded. The Stormwater Program Handbook is Handbook number 13 at the end of this list. And the Stormwater Management Handbook page, the link to this page is provided in the slide header. Handbook reference materials are also included in the handbook. And this will include the NPDES Stormwater Permit Programs by EPA region. It will include general stormwater resources. It will include state transportation agencies, stormwater resources. And next, I'd like to pass this on to Scott Taylor, who will discuss the 6 minimum measures of the stormwater program. I apologize for the beeping. I think those are folks that are just calling in late, and it should quiet down here in a few when people log in and call in. Okay, Scott?
All right, thanks, Anna. This handbook provides information on the NPDES permitting program and the basic requirements for creating a stormwater management plan for a State Department of Transportation to comply with federal regulations. The federal regulations require 6 minimum measures in the development of a stormwater management plan. Many states have additional clean water regulations beyond the requirements described here. However, the basic framework provided will support and be consistent with state-specific requirements. It's important to understand local regulations when developing and implementing your agency's stormwater management plan. This handbook provides information to assist in implementing a stormwater management plan if one has already been developed. The 6 minimum measures were developed by the EPA specifically for Phase 2 stormwater programs. Some DOTs are permitted as Phase 1 entities and may have a somewhat different framework than the minimum measures that are built, that the minimum measures are constructed around. But the items discussed here are relevant for either a Phase 1 or Phase 2 program. I want to just give a brief regulatory background for stormwater programs. Regulations are based at the federal level in the Clean Water Act, and stormwater discharges are regulated by the Act. The NPDES program regulates discharges from municipal surface storm sewer systems, also known as MS4s, and includes highways, highway-related properties, transit facilities, and activities served by storm drain systems, often connected to and considered comparable to urban MS4s. Construction sites are also regulated by the Act. Construction of highways and transit and related facilities often results in soil disturbance of areas greater than 1 acre, and that requires special requirements under a separate NPDES permit. And lastly, a quick word about delegated authority. Most states have been delegated authority to regulate surface water runoff that may affect receiving water quality under the Clean Water Act. The U.S. EPA acts in an oversight role in these states, and currently only 4 states do not have full Clean Water Act authority. The 1987 amendments to the Clean Water Act required that MS4s, including those owned by transportation agencies, obtain stormwater discharge permits, effectively designating them as point source discharges. By definition, a source that is permitted under an NPDES program is a point source. Non-point sources, such as silviculture, do not have coverage under an NPDES permit. As mentioned previously, the U.S. EPA implemented the NPDES program in 2 phases, depending on the population of the municipality. Transportation agencies are considered a municipal permittee, even though a population metric does not apply. Accordingly, all transportation agencies are covered by either a Phase 1 or Phase 2 NPDES permit for stormwater discharge. Many transportation agencies are entering into a 4th round of Phase 1 permits that are issued on a 5-year cycle. However, some agencies have entered into the permitting system only relatively recently under the Phase 2 of the program. A transportation agency may be covered by multiple Phase 1 or Phase 2 permits by geographic region, either individually or as a co-permittee with other agencies or municipalities, and the requirements in each permit may vary even by geographic region. There may also be regulation at the state and local level. Keep in mind that state regulations cannot preempt federal law unless the state law is more protected. State law may regulate waters not federally regulated, with waters that are not waters of the U.S. Examples are those that aren't included under federal jurisdiction as defined in the recent Rapinos court case. Local regulations are generally not binding to a state agency. They may require transportation agencies to coordinate with adjacent NPDES permittees, such as municipalities, to enhance program effectiveness and ensure compatibility of stormwater quality approaches. It's also good to partner with municipalities to leverage program elements and funding. Compliance with NPDES stormwater permits is a requirement under federal law, but a well-designed stormwater management program also benefits the state highway system by supporting sustainability goals and reducing infrastructure costs. Some examples of that might include the use of vegetated conveyances that can reduce capital as well as O&M costs for stormwater conveyance. Open graded friction course overlays may improve stormwater quality and safety. Future full depth permeable pavement systems could also enhance these benefits. Additionally, programs such as sweeping and trash pickup provide program benefits for safety and aesthetics, as well as NPDES program compliance. And the reduction of pesticide use, chemical training, and personnel costs. Major elements of a stormwater program are management and organization, which addresses legal authority, access control, budget, and departmental policy related to stormwater quality management. The monitoring and discharge characterization program, which consists of planned activities to assess the quality of stormwater discharging from roads, highways, and other facilities. This element also provides information for runoff water quality prioritization and improvement. This includes identifying outfalls and characterizing the discharges. Project planning and design includes best management practices and other stormwater management program elements that are incorporated into transportation projects during the early planning, assessment, and environmental design phases of the project. The construction element describes compliance with stormwater pollution prevention plan and approval responsibilities, construction notifications, inspection of construction projects, and any other technical requirements of state or federal construction general permit compliance. This portion of the program complements the state or EPA general permit for construction activities. Roadway maintenance activities include roadway and transit facility maintenance that affects stormwater, such as maintaining the line and grade of ditches, the BMPs used to prevent and control pollution during roadway maintenance operations, and routine surveillance and inspection activities to ensure water quality is protected. This element would also include resurfacing, restoration, and rehabilitation in most cases, or the 3R projects. Facility operations include the pollution prevention techniques, maintenance activities, and other facility pollution prevention plan elements at the agency's maintenance facilities. Non-departmental activities include construction activities by private entities that encroach on the agency's property, third-party facility operations on leased parcels, and other third-party activities. Non-stormwater activities and discharges include those other than stormwater as defined by the NPDES permit, including spills, illegal connections, and illegal dumping, also known as illicit connection and illegal discharge, or ICID. Training includes a training program and plans for training of internal staff and external contractors. Public education and participation comprises a framework and plans to communicate with, involve in the program, and inform the public about stormwater protection. Location-specific activities address regional stormwater requirements, including involvement with the implementation of total maximum daily loads, TMDLs. Program evaluation is conducted for compliance with all of the stormwater management program elements, including construction and maintenance field activities. Measurable objectives include the objectives, activities, and implementation tasks that are to be performed to achieve stated stormwater management plan goals. And finally, reporting on applicable elements of the stormwater management plan, usually done in the form of an annual report or possibly through work plans, include proposed stormwater management plan modifications, non-compliance incidents, as well as the program effective assessment, which is our next topic. So at this point, I'm going to turn it over to Anna to cover the importance of conducting a program effectiveness assessment.
Okay, program effectiveness assessment. Now, stormwater programs are generally required to conduct a program effectiveness assessment. The California Stormwater Quality Association has developed a guidance handbook for program effectiveness assessment of MS4 stormwater programs. This information in this handbook is applicable to the DOT programs and is centered around 6 outcome levels. CASCA is currently updating its handbook, which should be out in a revised form sometime in 2010. The 6 outcome levels are: Level 6, this would be to improve receiving water quality, which is to achieve the highest level but most difficult to assess and measure. Level 5 is to improve stormwater runoff quality. It's easier to measure but requires a lot of data collected over time. Level 4 consists of reduced pollutant loads. Example would be, for example, drain inlet cleaning. Level 3 is regarding change in behavior. This is to measure, for example, public behavior change from a Level 2 outcome. And Level 2 is to express increase in knowledge and awareness. Example is a pollution reduction public education program. An example is, for example, the Don't Mess with Texas is an example. Level 2 would consist of improving your permit and swamp compliance, which accounts of required program elements defined in the swamp. So the program effectiveness assessment is currently conceptualized as a pyramid, but the goal is not to assess all stormwater plan elements at progressively higher levels, or rather to move to the most effective assessment level for the element being reviewed. A program effectiveness assessment should provide a structured way to measure the effectiveness of each element of your program and facilitate improvement in that element using feedback from the data analysis. The role of the stormwater manager is to define each element to improve effectiveness and hopefully reduce cost. There are many different ways to do this, but building a history of performance data is the best way to assess positive or negative trends. Outcome levels 5 and 6 measure improvements in effluent and receiving water quality. This may seem like the ultimate goal of any program, but there will always be important elements such as public behavior change that will not be assessed at this outcome level. Focus on measuring at the appropriate level and linking measurements between levels for the best program feedback. Most NPDES stormwater permits require some form of program assessment to continually refine and improve the program performance. The CASCA Program Effectiveness Assessment is just one method your organization can use to implement this part of your program. It provides a logical structure and approach. It is up to your agency to develop your own approach that best reflects how your organization implements your stormwater plan. Okay, a stormwater management plan, or commonly referred to as SWAMP, describes the DOT or the Transportation Agency's program and addresses stormwater pollution control related to planning, design, construction, operation and maintenance, and dewatering. Requires implementation of BMPs to reduce or eliminate pollutants to the maximum extent practicable, or MEP, as required by the Clean Water Act. MEP is generally considered to be based on factors such as technically feasible and related costs to achieve measurable environmental benefits. The SWAMP is designed to include an iterative process of use, evaluation, and modification, retrofitting of BMPs to provide continuing progress toward protecting water quality and achieving compliance with receiving water standards. It is good practice to prepare the SWAMP in collaboration with US EPA or the state regulatory agency. For construction activities, the SWAMP requires implementation of BMPs to reduce or eliminate toxic pollutants using best available technology economically achievable, or also commonly referred to as BAT, and implementation of BMPs to reduce or eliminate conventional pollutants using best conventional pollutant control technology, or BCT. This generally refers to a suite of BMPs that have been found through experience to be effective in controlling construction site runoff water quality. The SWAMP requirements apply to discharges exiting the site via BMPs and stormwater conveyances, including catch basins and drain inlets, curbs, gutters, ditches, channels, and storm drains within the agency system. The SWAMP may apply to discharges consisting of stormwater and non-stormwater resulting from maintenance and operation of state-owned highways, freeways, rails, and railroads, maintenance facilities, other facilities with activities that have the potential for discharging pollutants, permanent discharges from subsurface dewatering, temporary dewatering, and finally construction activities. The SWAMP addresses discharges that originate within the agency right-of-way and are carried through the municipal stormwater conveyance systems and flow into surface water bodies in the state. These surface water bodies include creeks, rivers, reservoirs, lakes, wetlands, lagoons, estuaries, bays, tributaries, and the ocean. So, switching gears to key issues to consider, the handbook's key issues section serves as a good reference check to ensure that your program is comprehensive and considers the elements necessary to make it comprehensive. You can see here the key issues to consider for the program framework. Primary among them are the SWAMP and a management structure to ensure implementation. Resource and funding. Similarly, here are the key issues for resources and funding. Staffing is a main issue, but all DOT programs should be aware in planning for potential liabilities that may face in the near and medium term, especially for TMDL compliance. Some of the more important elements for program implementation are collaboration with the MS4s. This can greatly leverage resources for additional effect. Collaboration with MS4s for TMDL compliance will be increasingly important to DOT programs. Perhaps the most important implementation element is communication and buy-in with upper management. A culture of environmental stewardship within the organization is very important to get the most from the DOT stormwater program. Good communication and tracking of compliance costs are good ways to ensure good collaboration with management. Operation and maintenance can sometimes be overlooked, but it is one of the most important elements. An ongoing inspection and program to ensure slopes are stable can be beneficial. and a tracking system for post-construction BMPs owned and operated by the state is essential. GIS tools can greatly facilitate BMP tracking and maintenance efforts and pay dividends when developing an annual report. So next, Scott will touch on potential compliance pitfalls and practical tips. Scott?
Okay, thanks, Anna. The EPA is currently conducting audits of DOT programs nationally. Some common deficiencies noted in these audits include compliance with construction general permit requirements on construction sites, disposal of maintenance waste and the operation of maintenance facilities, the uniform implementation of stormwater management plan requirements across the state, conducting general inspection and enforcement, and implementing the ICID program that I mentioned previously. BMP retrofit, whether alone or in association with 3R projects, is a major undertaking for DOTs. Retrofit of stormwater controls is relatively costly compared to building controls as part of new construction, particularly if right-of-way acquisition is involved. The DOT should establish a policy on BMP retrofit that includes approved BMP types, the access requirements, minimum treatment area requirements, and right-of-way acquisition guidelines. Here's just a few DOT examples of treatment BMPs that are retrofitted within the highway environment and support facilities. The BMPs shown here are all retrofits. The infiltration basin and the detention basin are within highway interchanges. The media filter is in a park and ride lot, and the infiltration trench in a highway maintenance station. We cover some of the minimum expectations of the U.S. EPA here and descriptions of how to address them using the structure of the 6 minimum measures introduced in the overview section. Since most states are authorized by the EPA to administer their own permit program, there is substantial variability in the precise expectations of each state. So for specific information, consult with your local permitting authority. There's a current NCHRP research program reviewing the various DOT NPDES permit types. This project may also be making recommendations relative to DOT permitting. Agencies, as I said earlier, hold either Phase 1 or Phase 2 permits. Stormwater management may be required on all projects statewide or just in urbanized areas. Some agencies are permitted by district or region, with each district possibly having unique and separate requirements. Many agencies are co-permittees with local jurisdictions. An agency may also be covered under multiple NPDES permits, either alone or as a co-permittee with other agencies or municipalities. Consequently, each agency needs to consider their specific situation regarding the level of implementation for each of the measures that we've shown here. We talked previously about the benefit of leveraging public resources for public education. Consistent message transmitted from multiple agencies in the state will have a much better effect in modifying public behavior. A national DOT anti-litter campaign may be worth exploring as a logical extension of this type of approach. Advertisers know that repetition is the key, as well as targeting the correct demographic in the local population. Your program effectiveness assessment should continually refine this element. Perhaps the most well-known of the examples of anti-litter campaigns is Don't Mess with Texas. This campaign took on a life of its own, and significant reductions in roadside trash and behavior change were measured by TxDOT. Public support is the objective of public participation and involvement. Meaningful public input into DOT stormwater program elements will help to ensure a consistent funding source for your stormwater programs. Communication of objectives is important, as is feedback to the public. A good example is the North Carolina DOT has developed a performance dashboard to provide public feedback on the efficacy of their environmental programs. Some examples of options for public input and involvement are shown here. Like all public outreach, a consistent ongoing program is important. Adoptive highway programs encourage individuals or groups to help remove roadside litter and debris and to report illegal dumping. Public meetings, workshops, and citizen panels can bring people, communities together to discuss alternatives and provide input concerning appropriate stormwater management policies and BMP implementation. And finally, participation with other agencies, schools, or community groups at public events encourages education, employment outreach, and enhances public safety. Illicit connection and illegal discharge, or ICID programs for DOTs, should have a somewhat different focus than for traditional MS4s. Cross connections to DOT storm drain systems are far less likely in areas with controlled access, but dumping can be a major issue along highways. Some specific tips for your ICID program are, for illegal dumping, identify dumping hotspots and post signage, restrict access, or increase patrols in those areas. For dry weather flow, it should be known that dry weather flow is prohibited in many NPDES permits, so eliminate irrigation excess and seal storm drain system pipe joints that receive groundwater infiltration. Training of personnel. Instruct your maintenance staff to keep non-stormwater and other pollutants out of the storm drain, such as water from concrete saw operations, surfactants from paving operations, grind dust, and material collected from sweepers, and not dispose of them and keep them out of, again, storm drains and waterways. Homeless populations or encampments can also be a significant source of trash as well as cause sanitation problems. Eliminating or moving encampments from within the right-of-way will minimize these sources. Another example of an illegal discharge is non-stormwater activities that occur in highway maintenance yards that result in discharges to the storm drain system. The most prominent of these is washing of agency vehicles and equipment in areas where water drains to the storm drain system rather than to the sewer. Washing vehicles in covered areas so that wastewater drains to the sanitary sewer helps avoid this problem. The EPA expects transportation agencies to develop, implement, and enforce a program to reduce pollutants and stormwater runoff from construction activities. Construction runoff from highway activities can prevent many special challenges due to the linear nature of projects, which result in numerous discharge locations at crossing of watershed drainages. In addition, the site constraints of working within a limited right-of-way can make implementation of many of the common erosion sediment control measures difficult. As mentioned, new effluent limit guidelines recently adopted by the U.S. EPA will create a challenge for DOTs in the future. ELGs include a new numeric turbidity guideline that will require extra vigilance to meet in areas, especially those that have high silt and clay content. The North Carolina State University Department of Soil Science has an extensive program investigating various ways to reduce turbidity from highway construction sites. More information on this can be obtained at their website. The Federal Highway Administration has adopted AASHTO Highway Drainage Guidelines, Volume 3, titled Erosion and Sediment Control in Highway Construction, dated 1992, to be followed on all construction projects funded under Title 23 of the U.S. Code. These guidelines do not preempt any requirements made by state law. Such requirements are more stringent. However, according to the guidelines, federal aid funds shall not be used in erosion and sediment control actions made necessary because of contractor oversight, carelessness, or failure to implement sufficient control measures. Suggested construction site pollutant erosion and sediment controls include permanent erosion and sediment control measures. These are preferably established and implemented at the earliest practical time, consistent with good construction and management practices. Temporary erosion and sediment control measures and practices are also coordinated with the permanent measures to ensure economical, effective, and continuous control throughout the construction process. A particular concern related to materials used in highway construction is the proper handling and disposal of concrete and cement. Concrete and cement-related mortars can be toxic to aquatic life. Proper handling and disposal to help minimize or eliminate discharges into watercourses will ensure that this toxicity potential is minimized. Most transportation agency construction will be provided by private contractors, so a comprehensive training program for contractor staff is essential. Linear infrastructure construction varies greatly from other land development improvement since the work area is constrained and the improvement may cross, as we said, many small streams and watersheds. It's helpful to have the contractor training programs that are developed specifically for linear infrastructure and be considered a requirement prior to the contractor being eligible to bid on DOT jobs. Stormwater requirements may also be included in requests for proposals and contracts for construction projects so that expectations for controlling pollution are known early in the process. Construction stormwater practices and compliance is especially important for transportation construction projects as they're generally large, very visible to the public, and can be nearby sensitive receiving water bodies. Next, I'm going to turn it back over to Anna to discuss practical tips on post-construction water quality requirements.
Okay, before I move on, I just wanted to remind everybody, if you have any questions that may come to mind, please enter them into the chat box, and Scott Taylor and I will go through those questions and respond to as many of those at the end of this presentation. Okay, continuing on to practical tip number 5 on post-construction water quality. Some of the largest differences in stormwater practices of transportation agencies are related to the management of post-construction stormwater quality. Some state transportation agencies, such as New Hampshire DOT, Washington State DOT, Maryland State Highway Administration, and Caltrans, require the implementation of approved stormwater treatment systems in all new projects where feasible. An emerging issue is hydromodification, the change in downstream hydrology due to the addition of impervious surfaces and the change in channel geomorphology. In addition, stormwater regulation is moving toward low-impact development approaches that emphasize pre- and post-project rate, volume, and increasingly pollutant load balance. Typically, vegetated systems are preferred, and infiltration, which is not always compatible in the highway shoulder, is emphasized. More research is likely needed to focus on LID approaches that are suitable in the right-of-way for various climate zones. WashDOT has developed several innovative practices, and DC DOT is retrofitting urban areas with LID-type measures. Best management practices to reduce the discharge of pollutants in stormwater include both structural and non-structural measures. Structural BMPs are facilities or devices that are engineered and built to capture and treat stormwater runoff, also called treatment BMPs, while non-structural BMPs include a variety of non-constructed measures or activities to reduce the generation of pollutants from highways and related facilities. A transportation agency may develop an approval process for BMPs that are shown to be effective for the constituents of concern in its runoff and compatible with its facility operations and maintenance practices. This approval process could also apply to construction site BMPs. The selection of structural BMPs for highways is different from that for municipal systems, since there is generally less right-of-way and maintenance access is more difficult. Controls that can operate passively and where deferred maintenance is not a problem are preferred. The International Stormwater BMP Database identifies BMPs that are effective in removing constituents of concern from stormwater runoff. Other good reference publication for treatment control design and application include National Cooperative Highway Research Program, or NCHRP, Report 565, Evaluation of Best Management Practices for Highway Runoff Control and FHWA, publication titled Stormwater Best Management Practices in an Ultra-Urban Setting, Selection and Monitoring, and FHWA publication on Evaluation and Management of Highway Runoff Water Quality. Non-structural practices that structural management practices for highway described previously are designed to reduce pollutant loads to the environment by holding and treating the highway runoff generated by precipitation. Non-structural management practices, on the other hand, are designed to achieve source control and can be used to augment on-site structural or other runoff management facilities. Most of the non-structural practices for managing highway runoff pollution are applicable to virtually all highway situations, even if a specific runoff problem has not been identified. Source control is emerging as one of the most effective controls for stormwater. DOT should investigate sources of constituents that are controllable in their right-of-way if they are of concern in local receiving waters. Integration on potential environmental impacts of stormwater runoff can be mitigated with sound planning procedures. The Council on Environmental Quality, or CEQ, specifically requires exploring all reasonable alternatives for preparing an environmental impact statement, or EIS. Many projects will not involve an EIS process, but will instead be prepared based on a categorical exclusion. It is important to integrate stormwater quality requirements into the project delivery process as early as possible for maximum success. For example, it is beneficial to select a preferred route that minimizes stream crossings, avoids wetlands, consider its impacts on endangered species and avoid areas that would present difficulties in establishing an effective erosion and sediment control program during construction. In addition, endangered species may have special requirements for water quality. The U.S. Fish and Wildlife Service provides a biological opinion through Section 7 Consultation of Endangered Species Act. It is suggested that Section 7 consultation, if required, be initiated as early in the project development processes as possible. It is helpful to develop water quality assessment guidelines to provide a consistent basis to assess the project impact on receiving waters during the initial environmental assessment for the project. A formal water quality assessment guidelines will ensure that environmental planning staff are aware of potential stormwater quality impacts and will create appropriate mitigation measures for the project. Practical tip number 6 on pollution prevention and good housekeeping. The operation of highway maintenance yards can lead to the discharge of pollutants in stormwater runoff as well as through non-stormwater discharges. As mentioned earlier, maintenance facilities can have compliance issues. Make sure each facility has a Facilities Pollution Prevention Plan, or sometimes referred to as FPPP, and that the staff at the facility are trained regularly. Routine inspections should be completed to ensure that potential pollutants are covered and contained. Pay particular attention to wash rack areas and where the drainage from the wash rack goes. It should not be plumbed directly to the site storm drain, but preferably should be covered areas with wash water directed to the sewer. Alternatively, the discharge can be directed to a BMP that is effective in removing sediment and oil and grease. Equipment maintenance should be performed indoors, and leaking equipment parked outside should be repaired. Special and other requirements specific to total maximum daily loads, or TMDLs. The Clean Water Act requires states to determine existing and potential beneficial uses of waters and to evaluate whether their current water quality supports these uses. When the water quality will not support the designated beneficial uses or designated uses, a TMDL is developed that apportions the maximum amount of the pollutants the water body can safely assimilate to all dischargers in the watershed, including transportation agencies. Under the Clean Water Act, Section 303D, states, territories, and authorized tribes are required to develop lists of impaired waters. The law requires that these jurisdictions establish priority rankings for waters. TMDLs are becoming a significant part of the DOT's stormwater programs. Load allocations for various constituents may require the retrofit of treatment BMPs and existing infrastructure. It is imperative that the DOT is involved early in the TMDL process to ensure parity in the development of load allocations and provide lead time to develop an agency-specific implementation plan. Integrated planning is also essential. Make sure you understand that other TMDLs may be developed in the same watershed in the future to allow the retrofit of BMPs that can meet the load requirements for all anticipated constituents if applicable. This slide shows the 303D listed water bodies in the U.S. currently identified as being impaired. Over the past 10 years, the number of listed water bodies has approximately doubled. This case is expected to continue as more and better monitoring information become available. And once on the 303D list, a TMDL, or total maximum daily load plan, is developed. Construction sites may also have to meet the requirements of TMDLs. New construction general permits may incorporate certain constituents by reference. So review your general construction permit language to determine the status. Construction projects may also be subject to Section 404 and 401 requirements, which also include water quality conditions to be met. If you are named as a stakeholder in a TMDL or think you may be, a basic checklist for TMDL processes: identify activities required under the agency's stormwater permit. Track the 305B report for the state's agency, which is the state's water quality assessment, and constitutes a potential watch list for water bodies that may become listed as impaired or included in the 303D list. If a water body in which the agency's facility's discharge becomes listed, determine if the agency's discharge contains the constituents of concern and in what concentration. participate in the Section 303 delisting process, and provide the regulatory agency with data regarding the quality of the agency's discharge for the constituents of concern. Participate in the development of the implementation plan. Avoid plans that are set arbitrarily and non-technical reduction goals. An assessment of the water quality standards may be appropriate. Avoid implementation plans that do not allocate loads to each NPDES permit holder or stakeholder. It is important to have a quantified load allocation. Some implementation plans leave it up to the dischargers to develop load allocation. Develop guidelines for structural BMP retrofits. BMP retrofit will most likely be required to meet assigned PMDL load allocation. A BMP retrofit policy to establish cost guidelines for items such as right-of-way acquisition, utility relocation, and storm drain system redesign is important. Regarding program development, developing the SWAMP in consultation with the various divisions within the agency is highly recommended to ensure that the requirements have an owner and are compatible with existing work practices. Similarly, the SWAMP can also be developed in consultation with the regulatory agency to streamline the approval. Regulatory agencies are not always familiar with the unique requirements of linear infrastructure and transportation. The plan development process within the regulatory agency may also need to include information regarding project, planning, design, construction, and operation. Failure to develop and implement a SWAMP can lead to, or stormwater management plan can lead to violations of the Clean Water Act and may be subject to fines, lawsuits, and substantial delays in project implementation. Documentation and record keeping. Most stormwater permits require the submission of an annual report documenting the activities undertaken by the agency during the past fiscal or calendar year to reduce the discharge of pollutants to receiving waters. It is therefore helpful to keep detailed records describing all the activities that were conducted during the year to improve water quality, as well as activities that impact water quality and any improvements that were made from the previous year. The use of a database to collect information needed for the annual report on a real-time basis is highly recommended. Basic program information will be needed from each of the divisions within the agency. Annual reports are generally due within 6 months from the termination of the reporting period. Planning is important, as obtaining information on short notice can be a challenge. If annual report data is entered into a database throughout the year as it is collected, staff preparing the annual report can query the database for most of the necessary information. The information collected for the annual report can be used to help the agency focus its efforts and update the SWAMP to make future actions more successful. And finally, I'd like to touch on available resources. Information on status, regulations, and guidance documents are available through the URL noted here. I just wanted to, since we had so many beeping earlier on, I just wanted to, again, recognize the sponsors of this webinar before we launch into the questions and answers. So our sponsors and advisory panel members of this practitioner's handbook, I want to thank them for helping us facilitate this live online conference today, which includes the AASHTO Center of Excellence and the Federal Highway Administration. And just quickly, the panel that oversaw the development of this handbook include Rachel Herbert from US EPA, Kate Kurgan, Damon Fordham, and Wayne Kober with AASHTO, Pat Kazinas and Dan Gear with FHWA, Elizabeth Velasco with Federal Transit Administration, and the representatives from the state DOTs include Scott McGowan, Judy Ruskowski, Karuna Pujara, and Marcus Anderson. And with that, we'll launch into questions that have been posted through the chat box, and if you have any follow-up questions at the end of this, please do not hesitate to send an email to either myself, Anna Lanton, or Scott Taylor, and our contact information is shown here on the screen.
Okay, Anna, well, the first question we have is from Jerry Cheney. He says, if the NPDES regulatory authority in our state believes that the state DOT must abide by all local, statewide permits and ordinances, is this consistent with EPA guidance? I think this is an excellent question. I'm not aware of specific federal guidance on this issue, but I think that generally the EPA supports a watershed approach and collaboration among dischargers to achieve what is the common objective of protecting receiving water beneficial uses. So I think that the general spirit of cooperation is definitely encouraged, if not required. I think that specifically whatever is in your NPDES permit is what you are responsible for doing. Next question, what is the source of the BMP costs on the retrofit slide? Is this in the petitioner's handbook?
That source is from a study that we had conducted on behalf of Caltrans. If you Google Caltrans Stormwater Program, the front page of that shows a highlight on a BMP retrofit study that was conducted, and we had tracked the construction costs for this retrofit program were about 30-plus BMP locations were constructed as part of a retrofit program. We tracked the costs that it took to construct them and monitor the operation and maintenance costs, and that's how we were able to compute the life cycle costs. So again, just Google Caltrans construction or Caltrans stormwater program, and the front page should be the BMP retrofit pilot report.
Another question. It's from Alabama DOT. Pollutant concern for DOTs is sediment. Will DOTs be required to monitor for pollutants other than sediment for TMDLs? I would say absolutely. There's also, I think, DOTs are being named that I'm aware of for
metals and nutrients.
Metals, nutrients, even impervious cover is popping up. Certainly salt in the Northeast is also a problem. So there are quite a few constituents concerned that DOTs will be a stakeholder in for TMDLs.
And something to keep in mind, once there is a TMDL that becomes essentially a watershed plan, that DOTs will need to collaborate with the stakeholders, and in general, the lead stakeholder will need to develop and implement a monitoring program for that TMDL. So that may be a cost-shared effort for the DOTs that you participate in, not necessarily do all the receiving water monitoring, but you can participate in TMDL regional monitoring programs. Now, most DOTs have a characterization program, so it's also good to monitor edge of pavement or edge of right-of-way for constituents that are anticipated for listings under the Section 303D or TMDL, so you're aware as to how that compares to the impairment that's causing the constituents and the concentrations that's resulting in impairment to the water bodies downstream. Okay, the next question from our camera line, what is the status of EPA's ICR? How do you think it will change the NPDES program? We don't have that information at this time, Mark, but maybe what we could do is get back to you via email. I do know that it's in process, but we'll have to get back to you as far as where they are in that process and how that would affect the NPDES program. Let's get the next one.
Next one is from Henry Barbaro. Level 6 is improving receiving water quality. Shouldn't there be some sort of problem measurement and or description in the first place? I think that that's very true. I think that for the constituents of concern that you have coming off of a highway right away, that you would definitely want to be defining a program to look specifically for those types of impairments in the receiving water. So it's really, again, the highest level outcome in looking at your program, and I think it's something with the tools that we have right now is very difficult to implement, but represents kind of the ultimate outcome of what you would want to see from a good and well-implemented stormwater program.
Okay, next question we have is, this is coming from Kurt. You mentioned in an earlier slide to send facility wash water to a sewer system. please clarify to participants that before any connection can be made to sewer system, the agency needs permission from the city, county, district wastewater treatment plant. And that is definitely a must. Before you connect to the local sewer system, there needs to be permission, and in general, sometimes that may include monitoring before you discharge too. Pre-treatment of discharges from wash water facilities is required. Absolutely agree, especially for equipment that is used in muddy areas or have a lot of sediment attached to them. There sometimes can be pre-treatment that's required because it tends to clog up the wash facilities, and we've seen that in other DOT wash facilities also. And a secondary comment there was wash facilities may not be piped to septic tank leach field system. Yeah, that would cause the septic tanks to get overwhelmed and not function. I agree with that.
Next question from Henry Barbaro. Let's say that the goals of the TMDL program have been reached, given our society is driven by growth, which includes ever-expanding areas of pavement. What requirements will new development face? I think you're seeing that in a lot of the new NPDES permits. Certainly low-impact development type approaches are key, and that's really looking at keeping post-development hydrology similar to or equal to pre-development hydrology, and that would be for peak rate, volume, and timing. We're also seeing post-development pollutant loads being matched to pre-development pollutant loads. So far, I've really only seen that in Maryland, but I think that is kind of another steps that could be taken. But currently, LID and mimicking pre-project hydrology is big, as is the reuse of stormwater.
Okay, next question here, and we might need to get back to you, Wes, on this. Question is, are you aware of any unique funding mechanisms employed by DOTs for stormwater management? Now, funding for DOTs are unique, state by state. This is probably a really good question for Pat Kazinas, who I don't believe is on this call, but I would get probably the best way is to be in contact with your FHWA liaison for what funding mechanisms have worked for other DOTs. Sometimes, or in general, I think for a lot of DOTs, they rely heavily on gas tax within the state and other opportunities on cost sharing with leveraging your resources with local MS4s, using Adopt a Highway, and adding more assistance from Adopt a Highway agencies that participate in that. For example, adding to their checklist, maybe an ICID inspection. There are unique ways to try to achieve some of this requirement by cost leveraging.
Next question is from Craig. I'm not going to attempt your last name. From Vermont DOT. He's got has your research into MS4 TMDL compliance nationally revealed DOTs participating in or paying into local, regional, or statewide stormwater utilities to achieve compliance under these programs? We haven't looked at that, and to date, I would say there is not, but I think that's going to be a key element in the future, because DOTs are going to be named potentially in a lot of TMDLs as more and better receiving monitor data becomes available. And I think that in many cases, it's going to be appropriate for DOTs to participate in a more regional program that's driven by the MS4s as opposed to trying to take care of their pro rata share within their right-of-way. So I think it's a tool that needs to be developed, and there needs to be a lot of research and, I guess, input on that to get it moving, to have it ready in time for when most of these TMDLs start hitting the streets. And then I guess our last question here, and then we're going to be out of time, is how will road salting and de-icing be addressed? I'm not sure specifically in what context. Certainly that is a problem for TMDLs, and also just meeting MEP for receiving waters. I think that probably ground zero for a lot of that type of information is up in New Hampshire. They've got a lot of requirements for that, and you might want to contact Mark Hemmerline to see what he's doing in that area. So with that, I think that's all the time time we have. We thank everybody for joining, and again, we thank our sponsors, and specifically ASHTO and the Center for Environmental Excellence, and we hope everybody has a great holiday.
We'll be posting this webinar and the PDF of the slides on the ASHTO website. Give us probably a couple days, if not a couple weeks. Hopefully we'll have it up there in the new year. Happy holidays, everybody. Thank you.